Hey, good day, everybody, and this is just a little video covering one of the topics that we did not do in class. Is a bit of an easier topic, so I figure I would just do it in a video, right? And what we're going to be talking about today, we're actually going to be talking about shapes and the types of shapes. We're going to be talking about the perimeter, the area, and the volumes of shapes, right? So first off here, you could see I have some types of shapes, and we have the triangle, which has three sides, right? We have a quadrilateral, which comes in many shapes and forms, but they generally have four sides. We have a pentagon, which has five sides, and we have a hexagon, which has six sides, right? Now, you see we have some other shapes here, heptagon, octagon, and others, but with more sides. CSEC wouldn't really go into this area though, so you don't really have to worry about this too much. These are the main guys that CSEC will be testing on. So we definitely have to get into those in quite a lot of detail. So let's get it started. These are polygons. Now what a polygon is, a polygon here. A polygon is any shape that is bounded by straight lines. Yeah, so you could have many different shapes and you could have irregular polygons as well. And they're all bounded by straight lines, right? So that's generally what we call a polygon, and these are some of the basic types of polygons we're dealing with here. So just keep in mind the triangle, the quadrilateral, the pentagon, and the hexagon. And let's actually see now what are the different types of triangles. So we'll start to look at each one of these guys here separately, and we'll see that we have four main types of triangles. Now, I actually want to talk about this one, the right angle triangle first, right? This right angle triangle, what makes it special and unique is that this angle here is always a right angle. So that angle is always 90 degrees, right? We also use the word perpendicular, so that just basically means something that is 90 degrees, right? So it forms this straight corner here, and it's a very, very special triangle. This is a triangle, and you can see here one of the angles is a 90-degree L-shaped angle. Yeah, so this right angle triangle will actually be studying a lot in mathematics. Yeah. Some of the other types of triangles, we have this equilateral triangle, where all the three sides, so this side, and this side, they're all equal, and all of the angles in here are equal as well. So when you have the three sides and the angles are equal, then that's an equilateral triangle. An isosceles triangle is only when you have these two sides being equal, right? And also the base angles are equal, and that's an isosceles. And then you have a scalene triangle, which is like the mad triangle, where all of the sides and all of the angles are pretty much different. This triangle is kind of crazy. Nobody likes him very much, but he's still the most exciting one, you know? So, because, you know, you never know what to expect. So these are your basic types of triangles. Please get to know them. Get to know the differences between an equilateral and an isosceles. And as I said, the right angle triangle here, this is the guy that we're going to be looking at a lot in math, in coordinate geometry, Pythagoras theorem, all sorts of stuff require us to know a right angle triangle, right? So moving on to the types of quadrilaterals, and let me just shape this here, right? So a quadrilateral is a shape that has four different sides, and we could see here that we have many different types of shapes with four sides, right? So let's actually talk about some of these types of shapes here, and we have the kite. The kite, generally these two adjacent sides are equal, yeah, And then you have these two sides over here, and these guys are equal. And that will form a kite, right? A rhombus is where I have, and it's very much like a kite, but in this case, all of the sides are equal. However, these angles here could vary. Yeah, so these angles could, there are a range of different angles that these could be. So they could be almost anything. However, in a square, we see that all of the sides are equal, just like in a rhombus. But all of these angles are perpendicular or 90 degrees. And this little symbol here is the symbol for a perpendicular or 90-degree angle, right? Now, a square is also a type of parallelogram. And a parallelogram, you can see here, a parallelogram is where I have these opposite sides being equal and parallel. Yeah, so these sides here are parallel with each other. The opposite sides are parallel, and they're also equal. You can see here in a rectangle, we have these opposite sides being parallel and equal, and then these opposite sides being parallel and equal. So you could see here that the square is a type of parallelogram, but it's also a type of kite or rhombus, right? A trapezium, the trapezium on this side, the trapezoid and the isosceles trapezoid, we just basically refer to them as trapezium. I only have two sides being parallel, right? So this side is parallel to this side, yeah? But these two are not parallel nor equal at all. And these parallel sides, they obviously don't have to be equal. You can see this one is a lot longer than this one, right? Over here you can see that this is a short side and this is a long side, but they are parallel, which means that they'll never touch. They'll just keep going on to infinity, right? And well, these two sides on the side here, they are not parallel at all, right? So these are the types of quadrilaterals, and quadrilaterals are four-sided figures. Now, we have to talk about another shape that's actually not a polygon. Remember, a polygon is a shape that is bounded by straight lines. But we have here other types of shapes that are bounded by curves or circles, right? So the circle is a shape. It's absolutely not a polygon. It only has one side going all the way around. This is just one side of a circle, right? Now, there are many different parts of a circle that we have to get to know, right? Now, some of the most important parts revolve around the center of the circle, and we could see the center of the circle right here. Now this green line, this is the diameter, and it's the only line that passes through the center of the circle. And you can see it cuts the circle in half. Yeah, so you have this side of the circle being equal to this side of the circle, right? So the diameter does that. The radius also starts at the center of the circle and then connects to any point on this circumference. And of course, this outer perimeter here is called the circumference of the circle, and you're seeing the word up here. Yeah. So this radius here starts at the center and it cuts. So this radius here starts at the center and it goes to the circumference of the circle. So you could see that the radius is actually a half of the diameter, and this is a really important, super important property of a circle that we all going to have to remember, is that the radius is actually a half the diameter. This radius here is a half the length of this. So if this line represents my diameter, then half of that line will represent the radius. So this is the radius, this is the diameter of the circle, and these are two very, very important measurements, and we'll actually be seeing them soon. Another measurement that we will have to consider immediately is the sector. And the sector here, and we could see this is like a pizza, it's like the slice of a pizza. And it's bounded by two radii. So I have a radius on one side and a radius on the other side. And there is an angle here. And this angle we usually call angles theta. That's the symbol for an angle, right? And when you have these two lines bounded and you have them at an angle theta, they form a slice of a pizza, and this slice here is called a sector. So we'll definitely have to talk about sectors coming up. Now, one other thing to consider in a circle is that we basically have one angle, and that is the angle at the center. And if we start here and we go all the way around, the angle at the center of a circle is 360 degrees. And that is actually super, super important to remember. And we will be talking about that very soon. But I think that we all know or all have some idea that a circle goes all the way around and comes back to the start, and that when you go a full circle or a full revolution is 360 degrees, right? So we will be seeing this stuff soon. Now that especially for CSEC, these are your basic shapes that we will be dealing with, right? And you saw that we took a look at triangles, we took a look at quadrilaterals, we took a look at circles, and then we have a couple of other shapes here that we didn't really go into, like the pentagon and the hexagon, but we will see them eventually, right? Now that we kind of know about the types of shapes, let's talk about perimeter. Now, the perimeter of a shape is simply the distance around the shape. The distance around the shape, that is the perimeter of a shape, right? So we actually have to measure the distance around this triangle. So let's just say we measure it, and this is this side here. Let's just say this side is 12 centimeters. Let's just say this side here is 20 centimeters. And let's just say this side here is 8 centimeters, right? So the perimeter P of this triangle is the distance around the triangle. So we taken the 8 centimeters and we're gonna add it to the 12, and then we're gonna add it to the 20, and that will give us what? 8 plus 12 is 20, plus 20 is 40 centimeters, and that is the perimeter of this triangle over here, right? So it's simply just adding up the distances or the sides of the shape that we're dealing with, right? In this example here, we have a square. Just let me center that, right? In this example here, we have a square. And with the square, you know that all of the sides are equal. So basically, they just have to give you the length of one side. Let's just say one side is 10 centimeters, right? Then you are supposed to know that, hey, this side is also 10, this side is also 10, this side is also 10. So essentially now the perimeter of this square is going to be equal to the distance around the square. So that is the 10 centimeters plus the other side 10 plus the other side 10 plus the other side 10, which will be 40 centimeters. So perimeter is a really easy thing. You just basically add this side to this side to this side to this side. You add up all of your sides to find the total distance around the shape, right? Even with parallelograms, and it really does not matter what kind of shape it is. Let's just say this is 10 and let's just say this is 5, right? Centimeters, of course. The units are important, and we'll see why later on, right? So the perimeter of this shape will be simply the distance. So I'm taking this 10 and I'm gonna add this 5, and then I'm gonna add this 10, then I'm gonna add this 5. So 10 and 10 is 20, plus 10 is 30 centimeters. So the perimeter of this shape is 30 centimeters, and that's just the distance around the shape, right? Now, obviously, we could actually combine different shapes to form compound shapes, and compound shapes are when we have different shapes forming a complicated looking shape, right? And in this case here, you can see that I have this rectangular looking area here, and then this triangular looking area here, and all these kinds of things. So we have to find the perimeter of this shape, and you have to look at what they give you, because basically it's just the distance around all of the sides basically is what we want. Yeah. So what did they give you? So what did they give you? Well, this you see they gave you the length of this side here to be 12 centimeters. So the perimeter is 12 plus they give you this side here to be 7 centimeters. So 7 plus they give me this side here to be 6 centimeters. So that will be 6 plus they told me that this side is actually equal to this side, and that's what these little symbols mean, that they equal. So that'll be adding another 6 plus I'll add this side here, which is 2, plus I'll add this side here, which is 3, right? Plus, right, we'll see that this is given to be 8 centimeters, so we'll add this side here to be 8. And let's just say that they didn't give you this one, right? So you have to figure out what this side is. And we could use reasoning. We could see that, all right, this here is 7 centimeters. So that means that this distance plus this distance will give me the 7 centimeters. So if this is 3, then obviously this is going to be 4, right? Because 4 plus 3 will give me the 7 centimeters. So by deduction or by observation or calculation, I could work out that that last side is 4 centimeters. Yeah. And when I add all of this up, so the total perimeter of this entire compound shape is 48 centimeters. So we see here that they could actually combine shapes, all of these normal shapes, they could combine them to give us, you know, a compound shape. Yeah. Now the last thing that we have to talk about are circles. So the perimeter of a circle, right? Remember, a circle is not a polygon. The perimeter of a circle, they're referring to the distance around the circle, right? The full distance around the circle. And as I said, the perimeter of a circle, or the distance of a circle, is referred to as the circumference. So the circumference of the circle is the perimeter of the circle, or the distance around the circle. So the circumference is actually given by a formula that we just have to learn. And that formula is 2 pi r, right? Now we could see here that r is the radius, and they would usually give you the radius. Yeah. And pi, and we will talk more about pi in detail in another video. But for now, if you didn't know, pi is a constant number. It's actually a number that you have to learn off. And that number is That number is 22 over 7. So 22 over 7 is the constant number pi. It's also, you could also learn it as approximately 3.14. So this pi number is a number that you have to know by heart. It's a constant that is associated with all circles. So all circles and all circle formulas will have something to do with pi. And as I said, in another video, we will actually talk a little bit more about what pi is. But for now, we just need to know that it's a constant. It's 3.14 or 22 over 7. Any one that you want to use is fine, right? So the circumference of the circle, you just use this formula here. 2 multiply by pi multiply by the radius. So let's just say they gave us the radius to be 1. Yeah, right. So let's just say they gave us the radius to be 1 centimeter, right? So the circumference of this circle is equal to 2 times pi, which is 3.14, times the radius, which is 1. And when you do this, you'll work out to be 6.28 centimeters. So this circle here, for the circumference of a circle, we just have to learn this formula, right? Please don't forget it. So you can see that this topic has a lot of stuff that we have to just learn off. The types of shapes and the differences between different shapes, as well as perimeter and some formulas as well, right? Now, they can ask you for perimeter of a semicircle, right? And a semicircle here, you can see that they gave us the diameter, and the diameter is 6 centimeters. So remember, we would have to know that the radius is equal to a half of the diameter. So the diameter is 6, therefore the radius is going to be a half of 6, which will be 3 centimeters, yeah? And so from that, we could now find the circumference. But remember, this is a semicircle. This is half of a circle, yeah? So what we could do is we could use the radius, this radius here, which will be about 3 centimeters, r, right? And we could use this radius to find the circumference of a full circle, yeah? So the circumference of a full circle, 2 pi r, and that's going to be 2 times 3.14 times r, which is 3, and this works out to be 18.84 centimeters, yeah? So the circumference of the full circle, because we used this circumference of a circle formula, and that gives us the circumference of a full circle. So the circumference of the full circle is this, 18.84. So now we can say the circumference of the semicircle will be 18.84 divided by 2, right? And that equals to 9.42 centimeters. So remember, this 9.242 centimeters is the circumference of the semicircle. So that's just this curved part here. That is the circumference of the semicircle. So this curved part here is 9.42. If we want to find the perimeter of the shape now, we have to add that circumference of the semicircle plus the diameter. That's 6 centimeters there, yeah? So that will be 9.42 plus the 6, and now that is equal to 15.42 centimeters. So we could see here that for a semicircle, you would have to do a little bit of reasoning. You would have to reason that the radius is half of the diameter, and so you could find what the radius is, and then just use your circumference formula. And the circumference formula will give you the circumference of the full circle. That is the circumference being the distance around the full circle, right? And then when we divide that by 2, that means that we'll only have this distance, the distance of the circumference of the semicircle. So to find the full perimeter of the shape, we would have to add this distance here to the diameter, and that will give us the perimeter of the full shape. Now the questions can actually get a bit complicated when it comes to perimeter. You can see that we have a compound shape here, and they gave us some information. The information that they gave us is basically that this side over here is 35 centimeters. So this side is 35. Yeah, I could assume that if this side is 35, then that means that this side over here will be 35 as well. Yeah, and they tell us that this height from here to here is 28 centimeters, and you would notice that this actually forms the diameter of the circle. Yeah, so this is a kind of semicircle thing here, and they want us to find the perimeter of this shape. So you would see here that I would have to find this distance here, which is using my circumference formula, 2 pi r. Now since and I don't have to cut it in half, because I have 1/2 of a circle on this side, and I have another half of a circle on this side. So when I find the circumference of a full circle, that is basically the distance of this plus the distance of this. So I could just find the circumference of the full circle to be 2 pi 3.14, and then the radius, which is the diameter, 28 divided by 2, right? That is the radius, which is half of the diameter. And this works out to be 87.92 centimeters, right? So that circumference, this 87.92, is the actual circumference of the full circle, which is this half here, this distance plus this distance. So these two distances added together gives me 87.92. So now if I want to find the full perimeter, I have to add the 87.92, which is basically the distance of this side and this side, right, which form the full circle. And then I have to add it to this 35, so that's plus that 35. And then I have to add this 35 as well, plus this 35, right? And that will give us 157.92. So that's it. Oh, centimeters. Please don't forget to put your units, right? So that's basically it there for perimeter. And we could see that when it comes to perimeter, we just kind of add all of the sides up. So we add all of the distances of each side, and you just add them up, right? And it really does not matter the shape, you know, the perimeter is just the same. You just add all of the sides up, and of course they could give you a compound shape, so you'll have to kind of work out the sides sometimes. And then we have non-polygons, which are essentially circles or semicircles or anything with curves in them. And we will have to use this one formula, and it's just one formula, the circumference of a circle being 2 pi r. And please remember that r, the radius, is a half of the diameter, right? So once we know this formula, we basically figured out any type of question, essentially, right? The next thing we're going to be looking at would be area and finding the areas of these shapes.